In this deduplication video segment, we're going to talk about partition deduplication. And there's a couple of different aspects that I want to cover off here, particularly around the use of SAN versus NAS storage. A lot of these concepts are starting to change, especially with hyperscale, and as more people go to that commodity compute storage concept, this is becoming less of a talking point here. But I still think it's worth talking about because many customers are still using just normal deduplication, normal media agents with either SAN or NAS storage. When I talk about SAN storage, and I'll show you in a slide in a couple of minutes, I always use the example of SAN and DAS, direct attached storage, as being synonymous. Even though that disk storage might be out in a SAN environment, it's zoned directly to a specific media agent. Whereas with NAS storage, there is no zoning, it's a UNC path directly to the NAS device. Before we get into that, let's kind of go through the basic concepts of what partition deduplication is. So it's a partition deduplication database. In this example, I have 4 partitions. 4 partitions across 4 media agents. That's not how it has to be done, all right? You could have 2 partitions sitting on 1 media agent. In fact, if you are using hyperscale, a default 3-node block would have 6 partitions. So the 6 partitions for hyperscale is specific to hyperscale. And you would have 3 nodes, 2 DDBs, 2 DDBs, 2 DDBs, all right? So you don't have to put 1 DDB per media agent. Always know that later on in time, you could always go and relocate these. It's not that big of a deal. In this example, I'm going to use 4 media agents. I got my disk library in the back end, and I have my client that I want to back up data for. It's important to note here that our signature lookups are going to be scattered across these 4 media agents, but your data path will always be exclusive. All right? Now, I know what some of you might be thinking, yeah, well, we have multi-node backup and blah, blah, blah. That's not part of this conversation. We're not talking about file system backups or multi-node backups. What we're talking about is the concept of how partition deduplication database works. All right? So the data path is exclusive to this media agent. Signatures will go all across, and we're going to use an AND process. When we generate the signature, we're going to do a divide by. In this particular case, we have 4 media agents, so we're going to do a divide by 4. Based on that signature, that result of that divide by, we will put it to here, 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 or here. The way I like to do it, just for simplicity, is 0, 0 goes here, 0, 1 goes here, 1, 0 goes here, and 1, 1 goes there. Nice and simple, all right? You use that logic, scale this out as big as you want to get, all right? So client generates a signature. The 0, 1 signature sends it to this media agent. This media agent checks it in DDB, reports back. This is a unique signature. Great. It's going to log that signature in this DDB, but the block is going to go to here. All right? Nice and simple. Next one is a 1, 1 signature. Goes over here. Checks it in, says, it's duplicate. Tells the client, duplicate, tosses out the block, sends any metadata. Again, go into here. All right? So far, it's a basic concept. It's not that big of a deal. Important signatures will go to the DDBs. Data path will always be explicit. One of the examples that I like to use when I'm teaching this is, and this came about a long time ago when I was having a debate with someone in a class where they were saying the reason why we need these high-speed connections between these media agents is because we do a reconciliation process where we will align block signatures with the blocks themselves. That is not the case. Point being is, even though this signature exists here, this 0, 1 signature, the 0, 1 block went there, all right? So don't confuse the two. The example I would use is I have 1 DDB partition in Alaska, 1 in California, 1 in New York, and 1 in Florida. But my data path is going through New Jersey. Believe it or not, you configure it that way, it will work. It's not going to give you good results, but it will work. All right? So now we're going to introduce the concept of using a SAN configuration versus a NAS configuration. Same idea here. And what we had is we had that 0, 1 signature go here, but the 0, 1 block went here. The other thing is when we had that 1-1 signature go here, it said it was duplicate. Here's the point. It was duplicate. It was from a different machine that backed up. The different client, when it was backing up, its data path wasn't through media agent 1, it was through media agent 3. So now what I have is I have some of my data sitting here, signature checked in for this job over here, a separate job that went through media agent 3 with a signature that was checked out to be duplicate for this client, but the block is sitting there. All right? So you say, what's the chances of that happening? Well, pretty darn good. All right? The issue comes into play, and this is why I used the example of SAN and DAS being synonymous, because each one of these mount paths is zoned to this specific media agent. The issue comes up is if this media agent is holding on to a signature that was checked in here for this client and only the metadata was sent there because this media agent said, I already have that signature, block sitting over here, this media agent goes down, you might not be able to restore this data because when this media agent goes down, you sever that path to this LUN. So you have to be careful when you're setting these things up. So I'm going to go forward one slide here to talk about how this works with NAS. Same concept, except all of these media agents are now connected to UNC path to the NAS storage. It doesn't matter that the block that was checked in here was written through this media agent to here. If any one of these media agents go down, you will still be able to restore data back to this client because the available media agent will always be able to see all the storage in the NAS backend. So there's a couple of concepts that I want to talk about here, and then I'm going to backtrack to that SAN and throw in a couple of best practices here. A lot of people talk about how SAN is faster than NAS, and I'm not arguing that point. But the problem is most people get so caught up in backup performance. And to me, that's illogical. The reason being is once you baseline your blocks in the back end, your performance of your backups is more based on your DDB performance and less on your disk backend performance. So SAN or NAS is not going to have a huge effect if you have your DDB on spinning disks. Yes, that's going to be a problem, right? But the big issue is the restorability of that data. Forget about a media agent going down. Let's go back to the SAN slide here. Forget about just a media agent going down. Think about the restore of the data. When we back up data, data is going to be deduped at the client. That's by default, we use client-side deduplication. But when we restore that data is rehydrated at the media agent. We don't do client-side restore deduplication. All right? What that means is this media agent has to reconstruct a chunk and send it back to this client. And it has to reconstruct that chunk in a specific order. And if there are blocks that are sitting on other media agents in other LUNs, those blocks have to be sent to that media agent so it can reconstruct the chunk. So doing something like this with 4 partitions on SAN in the back end could have a huge negative effect on aux copies and restore operations. The problem is you're not really going to know that until you actually have to do the restore. All right? So I'm not saying don't use SAN because a customer might be saying, hey, I agree with everything you said, but it doesn't matter. We already purchased this stuff. We're not going to throw it all out and go and buy a NAS because a Commvault instructor told me to do so. But you may want to determine whether or not this 4 partition diagram is right for your environment. You don't have to do 4 partitions. Just because you can doesn't mean you should. So let's go through a couple of different scenarios. The first scenario is I have 4 media agents. I got about 500 terabytes of disk space sitting on the back end, and I just want to say, set it all up, let Commvault handle it. Okay, fine. You want to look at what the data is. And this is the very first question that should always be asked here, all right? How many media agents do I need? How many partitions do I need? How should I set it up? Very first question has nothing to do with that. Very first question is, how much data? All right? Oh, I got Oracle data, Exchange, SharePoint, SQL, file systems, all of this great stuff. Okay. How much data? Oh, like 12 terabytes. Okay. You need one media agent, one DDB. Have a nice day. All right? Well, I got all this data. Oracle, Exchange, SQL, file system. How much data do you have? I have 300 terabytes of data. OK, now we have to figure this out. All right? So now you have to go into more detail about what it is. You say, oh, we got like 100 terabytes of Oracle data. Oh, OK. And then the rest. So you say, OK, how important is that Oracle data for you? Because now we're not just talking about deduplication. We're talking about a database backup and archive log backups for Oracle. So now it's not just about the storage and the availability and the media agents and all that. It's also about making sure you have resources to get the jobs done, particularly for those archive files. So instead of having one big 4 partition, you might want to set up a 2 partition and a 2 partition. I'm going to allocate these 2 media agents just for Oracle. I'm going to allocate the other 2 for everything else. In addition to that, you also might want to say, I'm still going to set up 4 partitions because I'm expecting to grow. These 2 media agents will have 2 partitions each. These will have 2 partitions each as well. All my Oracle stuff goes here, which means I don't have to worry about virtual machine backups and file system backups eating up stream resources, and now my archive files can't back up. All right? So you have to think about this in a holistic approach. The first question is how much data. Then you start getting into what type of data. But don't lose sight of the bigger picture. Don't get caught up in just the partitions and the storage and the back end, the SAN versus NAS. Also consider what type of data it is. In the case of the archive files, it's about, in some cases, cleaning up disk into production so this way more archive files can be written. But it's also about the RPO, the recovery point objective. The more frequent you can get those log backups done, the shorter your RPO is. For file system and VM data, might not be a big deal, but for the log backups, it's absolutely critical. So by segmenting this data, not only am I saying this data is going to be managed, the Oracle data, with these DDBs and this storage, but stream resources are always going to be available because they're not going to be competing against other things. So in general, when it comes to partition deduplication database, just because you can doesn't mean you should. You need to think about the strategy, thinking beyond just the performance characteristics, consider the restorability of the data, and also what type of data it is. And then you need to design around that so you can achieve your RPO, recovery point objectives, and in the case of the SAN example, where you got blocks scattered all across different LUNs, your RTO, your recovery time objective. So that is partition deduplication in a nutshell.